Hello everyone, welcome to the part 2 or the second video of the physics higher tier mock exam feedback video. In this video I will be going through questions 3 and 4. Remember that question 3 and 4 were similar for the combined science and the separate science. Let's move on to question number 3. Question number 3 was on electricity and circuits. Question 3 part A, diagram 1 shows an electric circuit with two resistors R and S. These are the two resistors over here. Some of the values of the current are also shown, which is 0.6 amps and 0.4 amps. Now before I move on to the next part of the question, I want to make some notes on this. So what have they given us? They have given us a parallel circuit, which is shown because these two circuits are connected in parallel. There's a junction here. So let me label that junction, and they have given ammeters, and that's your resistor. Now let me make a little bit of notes on parallel circuits, and while we are doing that, let me make a little bit of notes on series circuits. First of all, parallel circuits. Parallel circuits I'm just going to discuss what happens to the current and the voltage in parallel circuits. So current in parallel circuits splits up at a junction. So when it's going into a junction, it splits up. As it comes out of the junction, it joins back again. And the voltage or the potential difference remains the same. So what happens in series circuits? Let me label that. In series circuits, current remains the same, and the potential difference or the voltage is shared between components. So just to give you an idea what series circuits are, if these two resistors were connected like this is what you call a series circuit. So R and S, the current would actually be the same, as current is the flow of electrons. You can make that definition separately, and the potential difference is shared. So if the power supply was 6 volts and if it were identical resistors, it will be 3 volts and 3 volts. Let's move on to the question and what they're actually asking. On diagram 1, draw a voltmeter to measure the voltage of resistor S. So they want you to draw a voltmeter. Now remember, the symbol for voltmeter is a V in a circle. So how do you connect a voltmeter across S? So you can either connect it below or above, right? Since I have space in between, I would connect it over there, right? I could put an arrow, right? The reason it's called the potential difference is because you're connecting it across, so it measures a difference in the potential as it goes in and comes out and gives you a value which is your voltage. Now part 2, deduce the readings on the ammeters. So what is the current in A1, which is over here, and the current in A2, which is over here? Now the current in the total current, so if the symbol for current is I, the total current is 0.6 amps. when it goes into the junction, 0.4 amps goes into resistor R. So the rest of the current goes through resistor S. So A1 is 0.6 minus 0.4, which gives you 0.2 amps. And what would be the current in A2? The current in A2, because the ammeter is connected past the junction, the current would have actually joined back together, so it would exactly be the same as the current that is going in, so that would be 0.6. Resistor R, part 3 of question 3. Resistor R has a resistance of 11 ohms. So the resistance of R is 11 ohms. Calculate the voltage across resistor R. So how do you calculate the voltage? We use Ohm's law equation, V equals IR. So the voltage is what we are trying to calculate. The current across R is 0.4 amps as shown above. So the current is 0.4 and the resistance they have given is 11, which gives you a value of 4.4 volts. 4.4 volts. Now let me point out some of the common mistakes that was made. A lot of students did manage to get this value unless you forgot the equation, and some of you failed to read this part of the question, which meant that you didn't get 1 mark for drawing the voltage across S correctly, and some of you did actually get this part of it wrong, where you thought it was 0.4 again, because as the diagram indicates 0.4, you thought it was simply going through A2, so you wrote an incorrect answer of 0.4. Let's move on to the next part of question 3. Question 3, part 4. Explain how the voltage across R compares with the voltage across the battery. Now they are asking you to explain, so you need to give reasons. The voltage across R and the voltage across the battery, because they are connected in parallel, as I said in the notes, the voltage will be the same. So let's start off by saying that let me use a blue color pen. The voltage across R and the battery would be the same. That would give us 1 mark. The second mark is for giving a reason, because they are asking you to explain. Since they are connected parallelly. That's all you need to say. Now for the next part of question 3, part B. A car headlamp has a power rating of 55 watts when the current in the headlamp is 4.4 amps. So they have given you the power rating. The symbol for power is P and the current is 4.4 amps. The symbol for current is I. State the equation relating to power, current and resistance. Now since you will be getting your equation sheet during the exam, you should be able to find this equation. Now since they are asking you to state, you can either write this down as a word equation or a symbol equation. It doesn't matter. The one thing that you shouldn't do is draw an equation triangle. So let me write the symbol equation first. Right? So that would be R, I and P. So the equation that links all three is P equals I squared R, and the word equation is power equals current squared multiplied by the resistance. Now these two questions are linked together. If you got this wrong, which means you would lose the next marks as well. It's a clever way of actually splitting a 4-mark question rather than just simply getting you to work out the resistance here. So calculate the resistance of the lamp. Now you would need to rearrange that equation. So let me put this equation into an equation triangle. So power goes on the top, I squared on one corner and R and the other corner. Since they are asking me to calculate R, if I block that off, I would have power and below is I squared. So power divided by the I squared. So what is the value of power? The value that they have given is 55 divided by the square of the current, which is 4.4 squared. This gives us a value of 2.8 ohms. So the final answer is 2.8 ohms. Now let me show you the marking scheme for this question and then go through some of the common mistakes and alternative answers that they would have accepted. So in the marking scheme for question part 3.1, correct voltmeter symbol used, voltmeter drawn in parallel with S, condone drawn in parallel with R or the battery. So you need to draw it with the voltmeter with parallel to S, and we got the current values right, 0.2 and 0.6. This order only allows 0.2, this order only 0.6. So there is no other alternative answers for that. For question A part 3, the equation that should have been used is voltage equals the current multiplied by the resistance, and we got 4.4, and there is no other alternative answers. Formula should be seen or implied by calculation, allow standard symbols, rearrangements, ignore C or C lowercase c for current. Now here, although it's a 3-mark question, they haven't mentioned, just simply writing 4.4 as the answer without any working would still give you those 3 marks. Question 3, part A, part 4. Idea that voltage across the battery is the same as voltage across the resistance, right? So we stated that, and the reason is battery and R are connected in parallel, right? That's the main reason that they are accepting. Or you could say no other resistive components on the loop with battery and R. Question 3, part B, either power equals current squared multiplied by the resistance or the symbol equation will be accepted. Question 3, part B2, substitution into the equation P equals I squared R, and you should have an overall value of 2.8 ohms. And they are giving 2 marks if you simply wrote that down without the answer. Allow answers that round to 2.8. Allow full marks for correct answer without showing the working. So writing the answer, final answer as 2.8 should be okay, but although I would recommend that you write the equation, do the working while you're practicing so that you get this skill spot on. Now let's move on to question number 4. Question number 4 was magnetism and the motor effect. The diagram shows the magnetic field between the poles of 2 bar magnets. Only one end of each bar magnet is shown. Complete the diagram by labeling the poles on the bar magnets. So let me go through the reasons for the answer that they are expecting. The answer that they are expecting is for it to be north and north. The reason for this is magnetic field lines have direction. So let me make this as notes below, right? So, right, magnetic field lines point north to south pole. So as you can see in the arrows, they are all pointing away from this end of the magnet in both cases. So this should be north because it's trying to move away from the north and move towards the south pole. Now, one of the common mistakes that was made by the students was you didn't pay attention to bar magnets, because we saw answers which were basically indicating positive and positive or negative and negative, which would be in reference to electrostatic charges. Now, for the 2 marks, getting the poles correct as north and similar poles was the 2 marks. If you wrote it down as south and south, although the poles are incorrect, because the poles are similar, you should have got at least 1 mark. Let's move on to the next part of question 4. Question 4 part B. Figure 11 shows 4 plotting compasses on a piece of cardboard. So as you can see, there's 4 plotting compasses. They are all pointing in the same direction, resting on a cardboard. State the reason why the 4 compass needles all point in the same direction. Why would they point in a very particular direction? It's only because, right, they are pointing to the Earth's magnetic field, right? Since they are pointing, or you could say aligning to the Earth's magnetic field or field lines. Next part of question. In figure 12a, a long wire goes through the center of the piece of cardboard. The wire is carrying a large electric current downwards. So there's a current going through this piece of wire which is pointing down, and the question is asking you to draw arrows on figure 12 to show the new direction of the 4 compass needles. Now, when there is a current through a wire, a magnetic field is produced, and the shape of this magnetic field is circular, right? So what they want is for you to determine which way will it be actually pointing. So if you were to draw the shape of the magnetic field, right, let me redraw it, right? If that's the piece of card and you've got the wire and the card like this, right, the magnetic field should be circular, right? Now, will it point clockwise or anti-clockwise? Now, the rule that you need to use is the right hand grip rule, right? Now, if you want reference to this, have a look at page 170 or page 404 in the Combined Science Physics textbook. Although the diagram is given in the textbook, it's not very clear. I would recommend that you look this up or Google this, which will give you a much better understanding. Basically, what that the right hand grip rule means is, if you imagine if you can grip the wire. So let me say that the pen is the wire and the pointed end of the pen is the direction in which the current is flowing. So if you were to grip the pen, right, with your hands, and the thumb should be pointing in the direction of the current. So my hand should be pointing like this, right? My fingers are actually pointing in the direction of the magnetic field lines. So it would actually move in the clockwise direction, right? So I would draw an arrow like this, right, to indicate it's actually moving in this direction. Let me move on to the next part of question. Question 4 part C. Figure 13 shows the magnetic field around a solenoid P and the magnetic field around solenoid Q. So what is a solenoid? The solenoid is basically a coil of wire wrapped around an insulator, such as like a cardboard. and the wire should be carrying a current. So there's no the inside of the coil of wires shouldn't be a conductor. So you have two solenoids P and Q. And what are they actually asking for 3 marks? Explain the difference between the two magnetic field lines. So you need to give reasons and you need to identify the difference. So first of all, let's identify the differences. It is very clear that there is more magnetic field lines in Q than in P. So if I label this here, more field lines, right, and that's less field lines. Now as you can see, the arrows are indicating the flow of current. So in here the current is actually flowing from the bottom, and for Q it's actually flowing from the top. So if I say current in, right, here in P it will be here the current is going in from the bottom. Now there's a third difference. These magnetic field lines, the arrows are indicating for P they are all pointing down, which means that this should be the north pole and this should be the south pole, because the magnetic field lines go from the north towards the south. And here is in the opposite direction, which means that this is your south pole and that's your north pole. So as you can see, there's 3 differences. You need to give reasons because they are asking you to explain. So you need to say why. So how do we answer this question? First of all, I would state the difference, right? So let's start off from there, right? The magnetic field lines in Q is bigger than in P, right? Since there is more magnetic fields, right? Again, this part of the answer is not necessary. They are asking for the difference in the two magnetic field lines. So I've said they are bigger. I would actually use the word stronger, right? The magnetic field lines are stronger in Q than in P. Now let's give a reason. Why would this be, right? Since the only reason, what you are not seeing is the only reason that the magnetic field lines can be affected is by the strength of the magnetic the current flowing through the wires. The other factor that actually can affect the magnetic field lines is the number of coils. Now as you can see, if I count the number of coils, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 coils. In Q, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So they have the same number of coils. So the number of coils is not affecting the strength of the magnetic field here. The only thing that can affect the magnetic field strength here should be the current. So, right, since the current in Q is stronger or bigger than in P, right? Right. And another difference for the 3 marks, I would write the other difference as well. I would keep on pointing out the other difference. The other difference was the direction of the current. So, right, the current direction in P is opposite to that of Q. So its magnetic field direction is opposite as well. Now, before I move on to the next part of the question, looking through the overall answer, ideally what you would want is, in the exam when you write the answer, you would look at the answer and see if are there any bits that you can actually add. Now, looking at it, where I'm saying the magnetic field lines in Q is bigger or stronger, I could add the word, right, the better word would be is more concentrated or closer, right? When the magnetic field lines are closer together, that indicates that it is strong. I would actually add that as part of the answer. So you should read your answer once you write it, just in case, so that you can add a little bit more information in your exam as well. And it's totally acceptable if you add a little bit more by using an arrow, just like I did. Let's move on to the next part of question 4. Question 4, part D. Figure 14 shows a wire between the poles of a magnet. So you have a magnet with the magnetic poles already pointing, and there's a wire which is carrying a current. So the current is flowing in this direction. And the magnetic field lines, remember, it goes from north to south. So it's going from north to south here, right, in this direction. The wire is carrying a current of 0.3 amps. So that would be the current. The strength of the magnetic field between the poles is 0.6 Newton per amp meter. The length of the wire inside the magnetic field is 0.2 meters. Length of wire is given by the symbol L, and the magnetic field lines is given by the symbol B. Calculate the size of the force, which would have a symbol of F, acting on the wire. So use the equation selected from the list of equations at the end of this paper. So what is this equation that they're referring to? So F equals BIL. So that is the force, the magnetic field strength, the current, and the length of the wire. So in order to get the 2 marks, you just simply multiply these values. So that would be 0.65 multiplied by the current, which is 0.3, multiplied by 0.2, which is the length of the wire, and that should give you an overall value of 0.039 newtons. So 0.039 Newton. Newtons. Next part of question 4, part D2. Describe the magnitude and direction of the forces between the wire and the magnet. Now, as you can see, this is a very interesting question because it links electric circuits to Newton's third law, and a lot of students failed on this question. Describe the magnitude, and very few students, there was 1 or 2 students who did actually get this right. So magnitude is referring to the size and the direction. So they want you to describe the size, right? I'll come to the size in a second, because the size bit that relates to the Newton's third law. We can work out the direction, and some of you did actually work out the direction. So how do you work out the direction of the force? So you would use Fleming's left-hand rule. So in order to work out the direction, you would use Fleming's left-hand rule. So what is this Fleming's left hand rule? Let me draw this next to the magnet above. So Fleming's left hand rule indicates that your thumb, your first finger and your second finger, when held in perpendicular directions. So, right? So this is going to be your force field or the magnetic field direction and the current direction, right? So the force is the thumb, first finger and your second finger, right? So as you can see, when I turn this around, the current is moving in this direction and the field is moving in the perpendicular to this. So if I point my hand like that, so the force on the wire is acting upwards, right? So that would be the direction of the force. So let's go back to the question below, right? So there is an upward force on the wire, so that gives us the direction. Now in order to describe the size, we will have to think about Newton's third law. Now what does Newton's third law indicate? Let me make a small note on this at the bottom of the page, right? Newton's third law, right? Simply put, every action has an equal and opposite reaction. So how do you link this to here? Going back to the question, they are asking you to describe the size of the forces between the wire and the magnet. So they are asking you to describe the force between the wire and the magnet. So if there is a force on the wire which is acting up, this is what we've said, there's a force on the wire which is acting up, then there should be, according to Newton's third law, there should be an equal and opposite force acting on the magnet. So this is what we are going to write for the next part of the answer. There is an equal but opposite direction force on the magnet. I think this could have been worded better. But let's have a look at the marking scheme, right? There is an equal, right? The force is equal in size, but opposite in direction force on the magnet. So let's have a look at the marking scheme for the entire question. Question 4, part A, both poles should be the same, that's 1 mark. Both poles labeled as north, that's your second mark. So, and for B, part 1, a reason which includes reference to the Earth's magnetic field. Ignore naming direction of north. So if you simply say it's pointing to the north, then it wouldn't be enough, but you have to make reference to the Earth's magnetic field. 4 arrows as shown. So as you can see, this is in the clockwise direction. Allow 1 mark for arrows pointing in the opposite direction, but otherwise correct. So if you had labeled it in the opposite direction as anti-clockwise, you would have got 1 mark. Part C of question 4, this is to do with the solenoid. So an explanation linking lines in Q are closer together in opposite direction. We mentioned both of them. The current in P and Q are in opposite directions, which we have done. the current in Q is larger than in P. For those 3 marks, as you can see, the information that they're looking for is very brief, right? Although my answer was a bit lengthy, right? The information that they're looking for is, are you talking about the how close the lines are and the direction of the current with reference to the current, right? There's 2 marks with reference to the current. A lot of students wrote answers but only wound up getting 1 or 2 marks because you failed to point out the current correctly or make references to your answer about the current. Next part of question 4. Question 4D, substitution of the values into the correct equation, and the answer was 0.039 newtons, and award full marks for correct answer without the work in. So we got that right. And question 4 part D2, a description to include the force on the wire is upwards, which we did. Force on the magnet is in the opposite direction to the force on the wire. Force on the magnet and the wire have the same magnitude, right? So which we have done in our answer. They are equal but opposite direction. So the size of the force is equal, right, but opposite in direction, and forces perpendicular to the wire are equal forces. So you could label them as equal forces. In fact, I would go back and say, right, they are equal in size. We are talking about the force over here. That brings us to the end of this video, part 2. The next video is going to be on questions 5 and 6, which would be the last video for the combined science. I will see you soon in the next video. Thank you for watching.